So guys, this is my third video in the sequence of engineering models, and today I will be discussing about a new engineering species, that is the water pump. You can take a look at the picture of the water pump I've pasted here. There's a pipe for the inlet, a pipe for the outlet, and the main rotating system. Today we will be learning new concepts and facts. I will be discussing about the parts of the water pump. We will take a look at the principles involved in the functioning and the working of the water pump. We will also learn the design by my own CAD model. We will talk about some losses and take a look at why efficiency is low in the hilly areas. So let's get started. Let us first define a hydraulic or a water pump. A water or hydraulic pump is a machine that transfers energy from its moving parts to the fluid passing through the pump. And that energy appears as an increment in the velocity or the pressure of the water. I will be now defining you new terms, that is the impeller, the volute, the mechanical seal, and I will be also talking about the centrifugal force. Let's take a look at our designed CAD model. This is my own design CAD model. So let me just tell you the basic parts. This is the impeller. This is the rotating part of the water pump. This is the volute. Volute is the part that is designed to accommodate water coming from the inlet. It is designed in such a way that it can minimize all type of losses. Then this is the impeller, that is the rotating part, which actually drags the water towards the wall. We have also a part that is called the mechanical seal. Mechanical seal is a type of part that actually fixed between the volute and the shaft of the impeller. Actually, it is like mechanical seal is a type of equipment that actually reduces all type of leakages through the pump. And the fourth term I stated was the centrifugal force. Centrifugal force is a type of force that drags the body outwards. So here, when the impeller rotates, like I took a look from the top view, when the impeller rotates, it actually gives a centrifugal force to the water or any type of particle touching these. So we have discussed all the things. Now moving further, I will be talking about the principle involved in the working of the water pump. Water pump works in the similar way as we suck water from the glass full of water. When we suck water from the glass, actually we are creating some kind of vacuum inside our mouth. Due to this type of pressure difference, the water from the glass actually drags towards our mouth. Let's also talk about the energy transformation. Then we will take a look at the CAD model to understand things better. So, this is the rotational energy of the impeller that gets transferred to the kinetic energy of the water. And that kinetic energy of the water appears as the pressure difference. So when the impeller rotates, it actually transfers its rotational energy to the water. Thus it appears as a kinetic energy of the water. Now the water, when strikes the wall, it appears as the pressure difference. We will take a look at the CAD model and I will make things easy for you guys. Now let's me just explain a Bernoulli principle first. A Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in the pressure or decrease in the fluid's potential energy. Let's take a look at the picture. Here, the pressure is high, thus the speed is low. The Bernoulli's principle states that if the pressure in a region is high, then the speed of the particles tends to be low in that area. Here, the pressure is low, but the speed is high. This is how Bernoulli's principles goes. Now let's Me explain to you all the things, the working principle of the water pump. So, in the starting, when we provide some kind of torque to the shaft of the impeller, that can be via motor that runs on electrical source, the impeller gets rotated by some rotational speed. When it rotates, it actually drives the particle sticking to the impeller with the same velocity as it is moving. Now, as the particle velocity inside the volute or the chamber is quite high, thus the pressure inside will be very less, as stated by Bernoulli. So the water from this inlet pipe get rushes towards the volute because of the high pressure difference. Now as the water enters this volute, the impeller is again rotating with some high speed. Now when the impeller rotates with this high speed, it actually gives a force to the particles of water tangentially. That I have already told you, the centrifugal force it gives to the particles of the water. The water then strikes to the walls of the volute. Now when the particle of water strikes to the volute walls, actually the speed of the water get completely to zero. Now as the speed get completely to zero, there will be a lot of pressure inside, as stated by Bernoulli, and the total energy is conserved. Thus the total kinetic energy of the water appears as a high pressure region. When the water strikes the wall, it gets completely to a high pressure region. Now, the pressure inside is quite high, and to the atmosphere or the exit pipe is low. Thus, the water rushes from inside to the exit pipe and thus to the surrounding. This is how a water pump actually works. We have talked about the working, the principles of the water pump, the Bernoulli's principle, and now we will take a look at how the atmospheric pressures determine the working of the pump. Now let us read line by line. The pump impeller rotates so as to create less than perfect vacuum. As I already told you, the impeller rotates so as to create vacuum so that water can be dragged from the outside surrounding towards the volute. So whatever be the pressure at that point, in this case the volute, so if the atmospheric pressure is low like in hilly areas outside, there will be no significant pressure difference between the volute and the outside surroundings, as the pressure outside is quite low and the impeller is making a pressure inside the volute low, so there is not so much significant difference between the pressure outside and inside. Thus a less amount of water will be like dragged towards a volume. Thus the efficiency of the water pump will be reduced. Thus, in hilly areas, these pumps are not much used. Instead, a two reservoir system called siphon is used to achieve the same task. You can learn about siphon on internet, or if you want me, I can demonstrate a slide to you. Now we will take a look over the losses in the pipes in the water pump. There are two types of losses. One is the major loss and another is the minor loss. Major loss is the loss which is due to the friction, and minor loss are all type of losses other than frictional loss. The frictional loss depends on the length and area of the pipe as well as of the volute, all type of systems, and these forces or these frictional losses are much more than the minor losses. Thus, we tend to neglect these minor losses and concentrate over the reduction of the major losses. We have talked about everything. Now, I hope you can design your own water pump at home You will be like simply needing a impeller that you can buy from the market, a volute that you can create at your home via old bottles, a pipe, and a motor that you can buy from the market. You can all design a water pump at your home. I hope you guys liked my video. If you liked my video, please subscribe my channel. And I promise you guys that I will be coming with new stuff, exciting models in the upcoming video. Thank you guys. Have a nice day.